Hello viewers, welcome to another episode of our lesson. If you get this video, don't forget to like, share, subscribe, click on the notification bell as well. This evening and then today we are going to talk about the linear function system. Okay, this equation on the board is a linear function. Linear function is not too different from linear equation. Okay, if you look at linear function relates two variables, the relationship between two variables. That is about linear function. And then the exponent, the highest exponent of the independent variable in the function is 1. That is linear function. So at this point, we will talk about how to find the equation of a straight line, how to find the gradient of a straight line, how to find the equation of a line when you are given a point and then the gradient, how to find the equation of a line when you are given two coordinates. Okay, and then how to find the gradient of a line when you are given two coordinates. That is basically what we are coming to do. Now let's see how to find equation of what? How to find the gradient of a straight line. Okay, finding the gradient of a straight line. Finding the gradient of a straight line. Finding the gradient of a straight line. Good. So we are going to look at how we can find the gradient of a straight line. Now, if you have a straight line like this on the board, when the dependent variable is already made the subject in the function or the equation, to find the gradient of that function, you look at the coefficient of x, okay, in the function. That is when the dependent variable has already been made the subject. So for instance, if I have y is equal to 2x plus 3, and then if I want to find the gradient, which is given as m, it is equal to what? 2. That is the gradient of the what? Of the line. That is why the dependent variable is already made the subject. But at the point that the dependent variable and then the independent variable are expressed as implicit, or they are not made, none of the variables has been made the subject. You have to make the dependent variable the subject, which is the y the subject. Now, after making y the subject, the coefficient of x, after making y the subject, becomes the what? The gradient of the line. A typical example is, let's say we have y plus 4x is equal to, let's say, 2. Okay, and then we have to find the gradient of this line. You see, at this point, the dependent variable has not been made the subject. So how do you find the gradient of a straight line? Good. You have to make y the subject. By making y the subject, you transpose the 4x to the other side. And that is going to give us y is equal to 2 minus 4x. Now, having the 2 minus 4x, what is the coefficient of x? Now, the coefficient of x is minus 4. So this coefficient of x, which is minus 4, becomes our what? Gradient. So m is equal to minus 4 is our gradient. I hope this is very clear. Good. Now we are going to look at when you have two coordinates. Okay, we are giving you two coordinates. We are asking you to find the gradient of these two coordinates. At this point, let's say we have a coordinate a. Okay, it's equal to, let's say, x1, y1. Another coordinate b is equal to x2, y2. Okay, now to find the gradient of this point, what is m? Is equal to the change in the vertical axis over the change in the horizontal axis. So that is equal to change in y over change in x. Okay, so m is equal to change in y, which is y2 minus y1 over x2 minus x1. Okay, so this is how to find the gradient when you have a point, when you are given 2 points. Okay, you have 2 points. So let's say we have 2 points given us. Let's say point A is given us 1, 2, and then point B is given us 3, 4. Now to find this gradient, you can name the coordinates. And say this is x1, this is y1, this is x2, this is y2. Okay, and then you are saying the formula is y2 minus y1. So where is our y2? Our y2 at this point is 4. So m is equal to our y2 is what? 4. minus our y1 is what? 2 all over our x2 is what? 3 minus our x1, which is what? 1. Now 4 minus 2 becomes what? Becomes 2. Okay, and then 3 minus 1 becomes what? It also becomes 2. So now our gradient, which is m, is equal to 2 over 2, which is equal to what? 1. Okay, so this is how to find the gradient of a straight line, and then the gradient when they are given 2 points. This is all about the gradient system. But before then, I want to take you through something. Maybe we have a fractional expression. You have a fractional expression like, let's say, y plus, let's say, y plus 2y plus 4x is equal to 7. And then you have to find the gradient at this point. What do you have to do? The normal trend is to make y the subject in the function. So you have to make y the subject, you have to send this here. So it becomes 2y is equal to 7 minus 4x. What do? You divide 2 by 2. Okay, so this is divided by 2, this is divided by 2, and this is divided by 2. So the 2 will cancel out. You have y is equal to 7 over 2 minus 4 over 2x. Okay, and then we know 4 over 2 is the same as 2x. So y is equal to 7 over 2 minus 2x. So now the gradient m is equal to minus 2. And that minus 2 becomes the coefficient of x. Beloved, thank you for watching this video. Don't forget to like, share, subscribe, and click on the notification bell. Thank you.